Welcome to the CoSpaceRobot family. CoSpaceRobot is an official platform for both RoboCup and RoboCup Asia-Pacific CoSpace Challenge. CoSpace Autonomous Driving Platform is powered by CoSpaceRobot Studio. Apart from the CoSpace programming interface, it provides interface in Scratch, Python, and C. Please visit our website to find out more.
If you are an absolute beginner, CoSpace Autonomous Driving FirstSteps is designed for you. In this session, we will give you a step-by-step guidance to the CoSpace Auto Driving. We hope it will help you to have a better understanding in the CoSpace Auto Driving for beginners and to take part in the CoSpace Autonomous Driving Challenge FirstSteps category.
Line following is probably the most common application in robotics. It is widely used in industries and even hospitals. If a robot can think, the thought process of a line following robot will be very similar to that of a human being. And that can be simplified into 3 actions: sense, plan, and act. CoSpaceRobot will give you a unique first-hand programming experience in such applications. Let's take a look at the CoSpace Virtual Robot. It is equipped with one color sensor to sense the floor RGB color, which is a short form for red, green, and blue. One gyro sensor to sense the robot's orientation. One ultrasonic sensor to sense the front obstacles, and 6 infrared IR sensors for line tracking. What is the logic behind the robot's thinking process when it tracks a black line? The 6 IR sensors mounted on the robot are like 6 eyes of the robot. When the first left IR sensor, we call it L1, senses the black line, the robot needs to move forward. When the first right IR sensor, we call it R1, senses the black line, the robot also needs to move forward. When L2 senses the black line, the robot needs to turn left slightly. When R2 senses the black line, the robot needs to turn right slightly. When L3 senses the black line, the robot needs to turn left rapidly. When R3 senses the black line, the robot needs to turn right rapidly. This process repeats forever in a loop, and this will ensure that the robot tracks the black line. Let's code a line tracking program in CoSpaceRobot.
For optimal performance, your PC laptop should meet the minimum configuration. Let's watch a video guide on installation.
Hello, good job. We are almost there. Let's click on the Experience button to see if our computer is compatible with this software. While we are at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome. It seems that our computer is compatible and our software is up to date. And now it's time to activate our software. So there are 3 options: Learn, Compete, and Experience. So for this example, we're going to use FirstSteps. Alright, we're going to click on Workshop Pack 1. The activation window has just popped out, so please make sure you're connected to the internet. and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive.
Double-click on the CoSpace auto-driving icon on your desktop. Now, choose the level and map, also known as the virtual environment. In this tutorial, we will choose the future city from FirstSteps for illustration. Frame rate, it is also called FPS, is a very important parameter. It will affect the robot performance if it is too low. You can check the frame rate on the status bar. It is highly recommended to keep the frame rate greater than 15 for robot smooth performance. If the frame rate is less than 15, you should change the display resolution to 1366x768. After changing the resolution, monitor the frame rate again. If the frame rate is still less than 15, you can change the rendering quality to low. The frame rate should be greater than 15 finally. To adjust the virtual environment, first, click anywhere in the virtual environment, and then press the Q, W, E, A, S, D keys to adjust the 3D view. If you press Shift together with the keys, it will make the movement faster. If you mess up the environment, you need to click on the control panel and then click on Ctrl+H together to reset the virtual environment to the home position. To manually control the virtual robot, first, click anywhere on the control panel, and then press the 4 arrow keys to move the virtual robot manually. As you know, there are IR sensors, ultrasonic sensors, RGB sensors and gyroscopes are installed on both real and virtual robot. While the robot is moving, the live sensor data will be shown on the control panel. Double-click on the CoSpace auto-driving icon on your desktop. Now, choose your level and map, which is also known as our virtual environment. For this video we will choose Future City Practice Field. Double-click on the AI button to enter the programming interface. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. Based on the analysis earlier, we now need to convert the logic into code which the robot can execute. The first statement should tell the robot that when L1 senses the white line, the robot needs to move forward. Step 1. Let's create a statement named L1 senses white line. Step 2. After the statement name is defined, we will add conditions to this statement. We click on L1 until it turns white in color. This means L1 will sense for the white line. Step 3. We should tell the robot what to do when the condition is met. In this scenario, the robot should move forward. That means both wheels should have the same speed. Step 4. Finally, click on Preview button to see whether you have set the correct wheel speed. Great! We have completed our first statement. Repeat the 4 steps above to complete statements 2 to 6. Statement 2. When R1 senses the white line, robot moves forward. This is similar to statement 1. Make sure we have set the same speed for both wheels. Statement 3. When L2 senses the white line, robot turns left slightly. This time, we will set different speeds to the left and right wheels. As the robot turns slightly, the speed difference should be small. Same concept applies to statement 4. This time, the robot turns right slightly. Statement 5. When L3 senses the white line. This means that the robot is almost off track, so the robot needs to turn left quickly. This time, we can set the left motor speed to be negative and keep the right motor speed positive. Same concept applies to statement 6. This time, the robot should turn right quickly. After we have completed our program, we should do a quick check that the logic is correct and make sure every statement has conditions and actions. Once you have completed programming, it is very important to save and build. Save means to save the most recent program that you have just completed. Build means to check syntax errors, create a C code and a dynamic data link file with extension DLL. Now you can click on the preview button to see how the robot will behave. If you wish to modify the program, click on the Stop button and you will go back to the AI panel to modify the program. Now, you can load the program which has been compiled as a DLL file using the Load button in the control panel. After successful loading, we can use the play, pause and stop buttons to control the robot's movement. We can monitor the robot's performance in the control panel. We can monitor the robot's movement from different perspectives. You can select different viewing camera from the menu bar. Choosing main camera will let you to have the global view or bird's eye view of the environment. Choosing CS-Bot front camera will let you to have a first-person view or driver's view. Choosing CS-Bot following camera will let you to have a helicopter tracking view. You can also to have the global view and first-person view in separate windows. Changing position and size settings will change the separate window attributes. Well done! CoSpace Autonomous Driving First Steps allows you to program the robot in Scratch. To do so, you need to create a new project, enter Program Coding page, and select Scratch mode. Let's add the first statement. When L1 senses white line, the robot will move forward. Now we can continue to add the rest of statements. You can view how to code CoSpaceRobot in Scratch on RCAP Academy YouTube channel for step-by-step guidance. CoSpace Autonomous Driving First Steps allows you to program the robot in Python. Let's take my first program as an example for illustration. Open my first program. Click on Python icon. Your CoSpace program will be automatically converted into Python code. The Python code consists of variable definitions, system functions, and AI function which you can modify. Let's look at the first statement. When L1 senses white line, the robot moves forward with both wheel speed plus 30. The highlighted segment in the right window shows the interpretation. Let's modify both speeds to plus 70 for statement 1 and statement 2. Save the Python code as my first Python. The Python code will have an extension of py. Load the Python file myfirstpython.py in the control panel. Run the program. Well done. You have completed the first Python program. If you want to have more example on how to code CoSpaceRobot in Python, please visit RCAP Academy YouTube channel. Let's work on Task 1 CoSpace Town. You should launch the Task 1 field. The Task 1 is to program the robot car to travel in the CoSpace Town. The robot car starts its journey from the start station. It must pass through all waypoints before stopping at the destination. To complete the task, the robot needs to track a black line. Let's write a line tracking program. Create a new project. Add the black line tracking program. Build and trial run. This is the sample code for your reference. I am sure that you can make a better program. Why is the line following program not working well for this line tracking task? We have to consider the robot's action at two junctions. First junction is the T junction after waypoint 4. At the T junction, or we say when 4 IR sensors on the extreme right sense the black color line, the robot needs to turn right rapidly. The second junction is the T junction after waypoint 10. At this junction, when 4 IR sensors on the extreme right sense the black color line, the robot also needs to turn right rapidly. This is the same as the robot at the previous T junction. How can we make the robot to turn 90 degrees? First of all, we need to specify the speed for both wheels. We set the left wheel to be +10 and right wheel to be -10. Then, we let the robot run for a certain amount of time without interruption. We call this duration. This can ensure accurate turning. If the duration for turning is too short, the robot will turn less than 90 degrees. If the duration for turning is too long, the robot will turn more than 90 degrees. After a few trials, we have found that 1.5 seconds is a good turning period for this speed setting. So we set the duration to be 1.5 seconds. This is the sample code for your reference. I am sure that you can make a better program. Now, let's work on the task 2. The task 2 is to program the robot car to travel towards the finish line. It must pass through all waypoints before stopping at the destination. In this task, the robot has to stay on the black-colored road instead of tracking a black line. Here is the logic for the robot movement. You can use task 1 as reference and program the robot. The sample code can be found in the PPT slides. Now, let's work on the task 3. The task 3 is to program the robot car to travel towards the finish line. It must pass through all waypoints before stopping at the destination. In this task, the robot needs to turn when it is close to the wall. This is called obstacle avoidance. The ultrasonic sensor is mounted at the front of the robot. It senses the front obstacles and provides feedback in cm. When the robot moves forward, we can monitor the live feedback data on the control panel. To program the ultrasonic sensor, you have to specify the range of distance as a condition, then set the robot action to be taken when the condition is met. Please write your code for the robot to complete the mission. The sample code can be found in the PPT slides. Well done. You have completed all tasks. Let's move on to the CoSpace Autonomous Driving Online Challenge. Let's work on the CoSpace Online Challenge, or as we call it, the 𝑖Cool Challenge. Double-click on the CoSpace Auto Driving icon on your desktop. First of all, you need to select the correct level. Then select 𝑖Cool Challenge tab. Choose the challenge map you will be working on. Analyze the map and complete the code. Save and build. Load the DLL from the control panel. Click on the Start button and monitor the robot's performance. When the robot reaches the finish line or when you click on the Stop button, an ICS file will be created. Save the ICS file and send it to the event organizer. Congratulations! Well done!
RCAP CoSpace Autonomous Driving Challenge Rules, FirstSteps category. This category is for beginners aged 12 and below. Welcome to the RoboCup Asia-Pacific RCAP CoSpace Challenge. Automation of routine tasks is currently a concept that interests many industries. Among the most revolutionary parts of it are autonomous vehicles. These are visions of the future of city infrastructure. The main ideas they all share are self-driving cars and shared mobility. Those are set to revolutionize the ways we navigate through cities. In CoSpace Challenge, teams are required to build a real robot, develop and program appropriate strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. In the CoSpace Autonomous Driving Challenge, students are required to plan an optimum path, code both real and virtual robots to navigate in a smart city. The autonomous car needs to pass multiple waypoints before reaching its final destination. In this smart city, there are roads, buildings, black and white lines, and waypoints. In the iCool challenge, there will only be a virtual robot. The robot has an IR sensor array and an ultrasonic sensor. Students need to utilize the elements in the smart city to plan the best path and program the robot accordingly. Let's take a look at the game process. The duration of the game is 8 minutes. That means the robot has to complete the whole journey within 8 minutes. At the beginning of the game, the virtual robot is placed at the start station. When it travels towards the finish line or end station, the robot must pass all waypoints in any sequence. It does not need to stop at the waypoints. The game ends when the virtual robot arrives at the finish line in the virtual world. If the virtual robot passes all waypoints and reaches the finish line, the team rank is determined by the race time at the finish line in the virtual world. If the virtual robot is not able to pass all waypoints, regardless whether it reaches the finish line or not, the race time for the virtual robot to reach the last waypoint will be recorded. The team rank will be determined based on the number of waypoints passed, followed by the race time.
The detailed rules can be found in RoboCup Asia-Pacific official website. RCAP Academy is an outreach initiative of the RoboCup Asia-Pacific RCAP Confederation. It aims to strengthen the RoboCup spirit with continuous outreach efforts through promoting robotics and AI to the general public. On RCAP Academy YouTube channel, there are plenty of videos on CoSpace Grand Prix, which is former auto driving, CoSpace Rescue and other RoboCup categories. It includes step-by-step guidance on CoSpace auto driving and CoSpace Rescue, teams sharing, highlighted games, tips and tricks, etc. They are ready for you to explore. After finishing CoSpace Auto Driving First Steps, you can move on to study more advanced contents in CoSpace Auto Driving U12 and U19.